So question 12 says, use the rational roots theorem to find all the real zeros of the polynomial function. Use the zeros to factor f over the real numbers. So again, we're still dealing with what we call real numbers here. So some things that we want to do here is, this is going to be the strategy that I'm going to lay out for you here is, the first thing we want to do is identify how many possible zeros there are. And that's going to be the degree of the polynomial. Since our function is f of x equals x cubed minus 8x squared minus 31x minus 22, we do have three possible zeros. Notice that we don't have to have three, there's three possible. So if we find three, we're definitely done. If we don't find three, there may be some extra work to do. So what we can do is we can graph and use the table on the calculator to identify any integer zeros. So remember, our table only does integers, not fractions and decimals or radicals. So let's start with that. Y equals, and then we'll type in this x cubed minus 8x squared minus 31x minus 22. So if we go to the table, what I'm looking for are zeros. So, and notice that if we use the rational roots theorem, notice that 22, it's going to be like, the p's are going to be the factors of 22, which would be if I leave my little table here, we would have 1 and 22, 2 and 11, 3, 4, 5, 6, 7, 8, 9, 10. Now that would be it. So we'd have like plus or minus 1, plus or minus 2, plus or minus 11, plus or minus 22. Q is the factors of the leading coefficient. Since the leading coefficient is a 1, that's just going to be a plus or minus 1. So P over Q are my possible or potential rational zeros. So 1 over 1 is just 1. 2 over 1 is just 2. 11 over 1 is just 11. And 22 over 1 is just 22. So those are my possible rational zeros, the potential ones. So we don't have to go past a negative 22 or a 22 in that situation. So if we just start inside and work our way out, let's start with a 1 and negative 1. Notice that negative 1 is a 0 to start with. So I don't see 2. What about 11? 11 was. Can we find one more? What about 22? No, let's go the other direction. Negative 2. Yeah, negative 2 is also a 0. So we did find all three zeros. They were all integers, luckily. So if those are the zeros, remember, these are your r's. So if you want to turn those back into factors, we have to go x minus r. So if r is a negative 1, that makes it turn into x minus a negative 1 or x plus 1, if you will. So remember, the signs will always change. So if you see a negative 1, when it goes back into a factor, it's going to be x plus 1. So the 11 is just going to be x minus 11. That's going to be a factor. And then negative 2 would be x take away negative 2, or in other words, that'd be x plus 2. So we would have that going on there for that. So it would be the factored form. And we do not have to expand that out. It says type your answer in factored form. So that's all we have to do is change these zeros back into factors. So remember, we would have x equals negative 1. We would have x equals 11. And we have x equals a negative 2. If we take one step the other way, we would have x plus 1 equals 0. X minus 11 equals 0. X plus 2 is equal to 0. So remember how we set factors equal to 0, and then these would all become back into this part if you think of the process going the other direction. So if I was trying to solve x cubed minus 8x squared plus minus 31x minus 22, usually we would factor it, set each factor equal to 0, and then find the zeros. Now we're actually finding the zeros first, changing it back to factored form, and then putting it into its actual factors. That's kind of our strategy for that problem.